Hey guys, before I start my lesson, I just want to say thank you for turning in that percent quiz last week. The more and more of you are turning things in each week, and that's really good to see, so thank you very much. This week we're talking about area. There is no quiz on this afterwards, but there might be in the future. So area is something we've talked about in previous weeks, and you've talked about it in your homeroom. But today we're going to expand it a little bit more and talk about some, funny cases where area we have to think a little bit differently. As you guys know, and I've taught you before, that area is base times height, or length times width. If you don't know this concept, you have to rewatch my older video about area and perimeter. That's just fine. You can go ahead and do that right now. But if you have that down pretty good and you can find the base times the height or the length times the width, keep watching me. So on area, little reminders too. We are not measuring the perimeter, the edge of the shape. We are measuring the guts of the shape, so the inside of a shape. Like if this was a fish house that was 10 feet long and 6 feet wide, well, how many square feet are in the inside? I have to measure to see how big this inside part is. We can't measure area with straight lines. Right? We can't be like, well, it's a foot here, foot here, foot here, foot here, foot here. I can't measure the guts of a shape with just straight feet or straight miles or straight inches. We have to measure area in squares because it's two-dimensional. It has a base and a height, or a length and a width. So the way we measure it is two-dimensional, and that's what area is all about. We measure base times height, or you could look at it like this. We measure in squares. If it's 10 feet long, I can go 1, 2, 3, 4, 5, 6, 7, 8, 9. I know they're not even. They're supposed to be even, though. And then I'm going to go 1, 2, 3, 4, 5. And, I could count each one of those squares, and I would bet you $1 million that if I went base times height, it would be 60 of these squares. So I use my formula really quick to get that. It would be 60 feet squared. And I go like that, sorry. 60 feet squared. That means my feet aren't straight. They're two-dimensional. Superscript 2 shows me that I have a foot by a foot. So the whole thing around, I know it doesn't look like it on a little board, foot by a foot by a foot by a foot. The whole square is a square foot. And that's how we measure with area. It could be square inches, which would be smaller, inch by an inch by an inch, an inch. A square yard would be 3 feet by 3 feet by 3 feet by 3 feet, or a square mile, a mile by a mile by a mile by a mile. That's how we measure the surface of things. Now that I've done that little recap too, I'm going to move on to something a little bit newer. Okay. One thing I want to show you today is that base times height, I'm just going to stick times base times height, only works for specific shapes. Four-sided shapes, quadrilaterals, such as squares, rectangles. And it also works for parallelograms, four-sided parallelograms, like notice it has a little slant to it. I didn't really overdo it there, but it has a slant to it. And I wanted to show you why base times height works for parallelograms today. And I'm going to show you kind of how to break it down so your mind can visually see why it works. For example, if I have a parallelogram, it looks like so. That's an okay drawing. It's a little slanted. And the base is 8 feet. And the side is 6 feet. A lot of times kids love to say, I'm just going to go 6 feet times 8 feet. Well, that would make sense if it was a rectangle, but one thing I want you to keep in mind, the reason I like to use base times height, is the base is 8. The height actually isn't 6. Because if I'm measuring how tall something is, I'm going to go to the very top and I'm going to go straight to the bottom. Right? Like if I'm measuring my height, I'm going to go from the tip of my head straight down to the bottom of the floor. Since this is a slanted side, it's not the actual height, because when things slant, they get like shorter and shorter and shorter and shorter until they're eventually flat. The actual height of this object would be kind of an imaginary line that runs straight down. from the tippy top of the shape to the base of the shape, a straight line, which is actually a little bit shorter than the slanted side. It would be more like, let's just pretend it's 5 feet. Okay? So when I do the parallelogram, I still have to follow my rule. Base times height. It's not 8 times 6, it's 8 times the real height. 8 times 5 equals 40 feet squared. Okay? Let me show you why that works visually. Like I said I was going to do, if I got rid of this side like this, it's still 6 feet, but see this little triangle that I've cut out here? Kind of like right here. If I were to snip down that dotted line with the scissors and rip it off, notice how I could slide it around and connect it to this side. Same triangle. Now, if I got rid of that and replaced it with this side, what shape do I have? I have a rectangle that is 8 by 5. That's why it's so important to find the actual height, because you can turn it into a rectangle with the same, with that same height there by moving that triangle to the opposite side. If you need to replay that on the video a few times, do it. It's worth seeing so you can understand why we still use base times height. But you can't accidentally do that slanted side as a height. I'll do another one like that just so you can see one more time. Okay, this one's more like a slanty square, I'm going to say. So I'm going to say it's 5 feet. In fact, I'm going to switch up the unit. I've been using feet a lot. It's 5 inches, and it's about 5 inches actually. Let's just say this is 5 inches. This slant's 5 inches. Right now I can't find the area because I know my base is 5, but notice 5 isn't the actual height of the parallelogram. It's a slanted line, or a slanted side I should say. The actual height is straight from the tippy top of the shape straight to the bottom, just like I said before, which maybe in this one, I'm just making them really easy, but maybe on this one it was 4 inches. Well, I have to follow the rule, base times height. 5 times 4 gives me 20 inches squared. Okay? Always using the real height. Another thing I want to point out too, I'm showing a lot of things at once, but 20 inches squared is the same thing as writing 20 inches SQ. A lot of people do that, inches squared. A lot of people write 20 square inches. When you see squared, 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 you need to think we're talking area right now. We're talking area. We're talking measuring in squares. We're talking measuring the guts of this shape. It's easy to draw on these perfect shapes like a square or a rectangle to draw the actual areas in. On a slanted parallelogram, it's a little bit harder to draw, and so you really need to know that formula, base times the actual height, so you don't have to worry about how many squares was that, or did I miscount, or did I draw it poorly. You just follow that formula. Last thing I'm going to say today, and it's a little bigger concept too, is base times height works for squares, it works for rectangles, and it works for parallelograms, but it doesn't work for triangles, because triangles look, nothing like these squares or rectangles. And I'm going to show you what a little trick so you can find the area of a triangle too, or the formula so you can find the area of a triangle. And it's actually base times height divided by 2. So you take the base times height and split it in half. I'll show you why that works. Here's a triangle. Okay, it's a right triangle. It's got a right angle right here. Now, if this was a, let's go 4 inch by 8 inch, okay, it'd be really tough to draw on the square inches in this one. Now, it's divided by 2, because if I go 4 times 8, that gets me 32 inches squared. It's not a rectangle, it's not a square. If it was, sorry, I made that look kind of weird, but if it was a square like that, it would have been 32. Make that corner look a little bit nicer. it would have been 32. But if you notice something, we're missing half of that rectangle, right? So it's only takes up half of this is the whole space. This is half is missing of the rectangle because it's only a triangle. That's why we always divide the area by 2. If it was a rectangle, it would have been 32. But since every triangle is half of a rectangle or a square or half of a parallelogram, I have to divide it by 2 because it's missing its other triangle, the upside down version of it on the other side. So 32 divided by 2 is 16 inches squared. It works the same way with parallelograms too. If I have a triangle that looks like this, I have to do base times height divided by 2. Let's just pretend it's 6 inches by 6 inches by 6 inches. Just like the parallelogram. This isn't the height. This is definitely the base. The height would be from the top straight to the bottom, which let's just pretend it's 5 inches. So, base times height. 6 times the actual height of 5 is 30. 30 inches squared. I'm talking area. But this is a triangle, so I have to divide by 2. Base times height divided by 2. Let me prove why. Look. If I were to double this triangle and flip it on its head, what do I have? It's a poorly drawn one. What do I have? A parallelogram. See? And parallelograms are base times height, but I'm also missing this chunk. That's half of the whole parallelogram. So this triangle, base times height, would give you this whole parallelogram. But I only have half of it. I have the triangle, which is divided by 2. 30 divided by 2 is 15 inches squared. Okay. Just concepts to learn as just a little bit of a recap for you too. I know this is getting to be a little bit longer video. But 2 main things I talked about today is your parallelograms work the same way as squares and rectangles. If you don't know how to find the area of these, you have to watch my other video first. But when you find the area of a parallelogram, you better make sure that you are doing the actual height of the parallelogram, not the side length, the actual height, base times height. This formula works for all 3 of these things if you find the actual height. The second thing I wanted to get through today was the area of triangles. A triangle is always the base times the height, just like regular. Base times the actual height. Say it's 4 inches this time, I don't know. Is 24 inches squared. But you always have to divide that by 2 because every triangle is half of a parallelogram or half of a rectangle or half of a square. So you always divide by 2. 24 divided by 2 is 12 inches. Whoopsies, that looks weird. 12 inches squared. That's the 2 main concepts of area that are a little bit tricky sometimes. And believe it or not, if we talk about area again in this class, we're going to be talking about how to find multi-sided objects beyond 4. So keep that in mind. If you need to rewatch the first video, if you want to watch this video again, go for it. I know this one got a little bit longer, but those are 2 concepts that you're going to need to know. Thank you very much.